In this video, I want to look at the solution to Trigonometry 2, exercise level 2, question 5. If you've not tried this question yet, please pause the video now and try it first before looking at the solution. So in this question, we have two circles with centres A and B. So let's draw two circles with centres A and B. And what we know is that these two circles intersect at points P and Q. We're also told that angle APB, so angle APB is a right angle, and we're given that angle PAQ is pi over 3 radians. So I'm just going to join up Q to B as well to form a quadrilateral. We're also given the length between A and B. So the length between A and B is 10 centimetres. And what we're asked to find is the length of the perimeter common to the two circles. So that is the total length of these two green areas here. So really what we want to find here is we want to find two arc lengths. Okay, so it would be useful if we could find the radiuses of each of these circles. So let me call the radius of the circle with centre B R2, and let me call the radius of the circle with centre B R1. And if we can find those two radiuses, we can make some progress towards finding the perimeter that we're after. Okay, well, we also know that this length here is R1. We also know that this length here is R2. So this means that the triangle APB and AQB are congruent triangles because all the side lengths are the same. So let's draw out the triangle APB. So the triangle APB, we know that this length here is 10 centimetres, and because those two triangles there are congruent, we know that this is half of pi over 3, so half of pi over 3, which is pi over 6. And then we also know that because the angles in a triangle sum up to pi radians, we know that angle PBA is pi, subtract a right angle, which is pi over 2, subtract pi over 6, which is pi over 3. So we have PBA is pi over 3. Well, this leaves us in a position to find PB and PA, which is what we want. This is R2 and this is R1. So this is just a right angle triangle. So we know that R2 is equal to PB, which is 10 times the cosine of pi over 3, which is just equal to 5. And we know that R1, which is PA, is equal to 10 times the cosine of pi over 6, which is 5 root 3. Well, this leaves us in a good position, because if we want to find the arc PQ from on the circle A, we know the arc length on circle with centre A is equal to R1 times theta, but in this case theta we know is pi over 3, so this is just 5 root 3 times pi over 3. And the arc length on circle with centre at B is R2 times a different angle, so let's call this angle phi, where we can see here that phi is 2 pi over 3, because we knew that PBA was pi over 3. So we know that this whole angle phi is double that. We are going to get that this arc length is R2, which is 5 times by 2 pi over 3, which is 10 pi over 3. So the total perimeter that we're after is just the sum of these two, which is 5 root 3 pi over 3 plus 10 pi over 3. And if we take a common factor of 5 pi over 3, this is 5 pi over 3, open brackets, root 3 plus 2, which is an exact value, but if we put that into a calculator, that is approximately 19.54 centimetres to 2 decimal places.